Please introduce yourself and briefly summarize your education and professional background.
Hi, thanks, Todd. Thanks for the time today. My name is George Skaros. I'm the Chief Executive Officer for Extreme Steel. I've been with Extreme Steel for about the past 3 years, but the company has been around for much longer. Started in the year 2000 by Kevin Rodney. My educational experience, I have a master's degree from the University of Pittsburgh, undergrad from University of Buffalo, and have had various roles. I've previously served as this chief financial officer for Extreme Steel and recently transitioned to CEO.
Okay, so you should know a lot about the company. Can you tell me a bit more about Extreme Steel then? What do they do with, you told me your role, but how do they play a role into the greater infrastructure industry?
Yeah, so Extreme Steel is it's a fully integrated steel fabrication and erection company. So we operate in and around the District of Columbia. We refer to it as the DMV, the District, Maryland, and Virginia, which is a very robust market, and we're fortunate to be here. Recently, we have started expanding outside of the traditional geography, just following our customers as opportunities present themselves. But we provide a fully integrated solution for steel construction, everything from the delegated design and some light engineering to procurement of materials, fabrication, of course, logistics, and ultimately the field erection. Our project managers manage the entire project from beginning to end. That's part of the value that we provide to our customers that differentiates us a little bit from some of the competition.
Okay, sure. So there's a lot of steel that can be used on infrastructure projects. Is there a particular kind that you do or don't make? Like I'm thinking like, I-beams or girders or things like that, or panels. What types of steel are you particularly fabricating?
Yeah, so we work with most products, but carbon steel is our bread and butter, right? So we, our partners either from direct from the mills or from the distributors will procure those products. For the structural, our fabrication business is really twofold. We do the core and shell, which is primarily structural, and then we refer to it as TI or the tenant improvement packages, and that's more miscellaneous and ornamental metals. So think railings and stairs, platforms, some of the lower weight members, but oftentimes are obviously necessary inside of a building such as a data center. So we specialize in both.
Okay, just to get a little more detail, could you maybe perhaps
Mhm.
pick a project that'd be a good example of some of the work that you do there?
We've done work, obviously over the past 25 years. We've had some really exciting projects, some that are more well known than others. We've done work at the White House. We've done work at the National Air and Space Museum, several banks and different company headquarters. Over the past couple of years, we've been focusing heavily on data center construction. So think of customers like your Amazons and Facebooks, Googles. We do work for all of those. We are a first tier subcontractor. So our direct customers are the large general contractors in the area, but the owners are obviously the site owners can vary just depending on the project type. But a lot of our projects you've probably seen or visited. Others, either on the federal side or the data center side, you may have not been inside, but you certainly would recognize it if you saw it.
Okay, sure. So let's just pick the data center projects. What specifically types of steel do you provide for them? How are they used in those buildings?
So, a data center, the core and shell, is very similar to most steel construction projects. So we're taking in the very large I-beams and creating the structures. We run them through our fabrication process. We have specialized machinery that'll do the processing, and then our team of certified welders and QC inspectors will do more of the smaller welds, but to create the frame, depending on the project, right? We may be shipping just processed beams that will get fabricated and attached on the job site, or it could be certain modular units, or we refer to them as skid packages for our electrical contractor customers. We're actually creating really, for lack of a better term, electrical rooms. So it's a steel box that will fabricate in our facilities, and then ship directly to their facilities to attach the electrical components to those prior to being shipped to a data center, for instance. So we work with all different kinds of metals, beams of different shapes and sizes. Some, some extremely large, some, some more common than others. But all kinds that go into the the core and shell construction.
Our audience is mostly the engineers on these projects. How would you work with them? What was it like a typical workflow of working with the engineers? What do you need from them? What could help the relationship between them if they, to smooth things along? Like some advice for our engineer readers on how to work with a steel company.
Yeah, so we do have at Extreme Steel, we do have a team of engineers that work primarily with the customer's engineers. So the engineer record will be on the owner side, working with the architects and the planning phase. When it comes to our teams, we specialize more in the delegated design aspects, engineering connections, so more light engineering. But our teams work hand in hand with the customers and with their engineering teams on coordination. And then, oftentimes um, we have recommendations on value engineering or better connection types or just suggestions because we do this so often that we will pass those recommendations over. Oftentimes it leads to design changes. And what we're seeing more and more recently is we're being brought in earlier and earlier. So I think that's really the key is the coordination and timing. So often in our business, the schedule is even more than the financial aspects. The schedule is even more important. So the earlier we can get brought in to help with the design and put the teams together, really is where we see the value creation and cost savings occur. But that's definitely the recommendation I would have. The earlier the teams can start talking and working through design, oftentimes we see better success in the field.
Okay, that's excellent. So based on the projects that you work on and where you're located, I would think that you would have especially insightful knowledge on the federal construction projects. Could you tell me some background about the operational and compliance demands tied to these projects and how have they changed lately?
Yeah, sure. So federal projects have always required significant documentation and coordination, but definitely over the past few years, that's been increasing. For example, we're seeing much more focus on domestic sourcing requirements, Buy America, Buy Clean initiatives, EPDs or environmental product declarations, carbon reporting. So the higher we're seeing higher expectations for BIM coordinations and clash detection. So from an operational standpoint, projects continue to get complex. But again, going back to schedules, the schedules are shrinking. And that could be either a data center, a military facility, transportation project, whatever that is. The biggest challenge is the amount of information keeps growing, but the time available doesn't keep up with that, actually going the other way. So success isn't necessarily measured by whether the structure gets built correctly. It's also measured on how well the teams manage coordination of documentation, sustainability requirements, and then overall project risk throughout the entire process.
Okay, that makes sense. And tying back to our audience again, how can the engineers working on these incorporate some of these new demands and these schedule tightening to, to stay up to, is there a way to know more about what's needed? I mean, can they work with the government agencies themselves or reach out to, companies such as yourselves to find out what they need to know?
Yeah, yeah. Specialty contractors such as Extreme Steel, right? That's really where a lot of people can fabricate steel or put a building up. Again, choosing the right partner and just maximizing the time available pre-construction, right? To coordinate with the teams, understand the requirements, the documentation is really just critical. So that planning phase.
Makes sense. Another thing I know that Extreme Steel is keen on is integrated delivery models. Can you tell me a little bit
Yes.
about what they are and how they're beneficial in today's infrastructure climate?
To me, integrated delivery is really about getting everyone involved early in the process and keeping alignment throughout the project. Traditionally, the different functions, engineering, detailing, fabrication, are often treated as separate functions. Information gets passed from one group, but sometimes problems aren't discovered until they're in the shop or even worse in the field. So an integrated approach really helps to bring those groups together earlier. When the engineers and fabricators and field teams are working together towards the same goal from the beginning, more oftentimes than not, issues get identified. Construction, the constructability improves, and just much more efficient in making decisions. So in today's environment, everybody's dealing with labor shortages and schedule pressures, and more and more supply chain challenges are becoming prevalent. The level of coordination can make a significant difference. At Extreme Steel, again, we are fully integrated. So from the design aspects to partnering on the delegated design, to the procurement of steel, the fabrication logistics, and the field. It gives us a lot of control over the schedule. It helps our QC processes, and it really ultimately helps our customers, because we have our project management team is some of the best in the industry and have been in the industry really their entire working careers. They've done everything and have seen everything. So they're that one point of contact, which is just makes everything more efficient for successful delivery.
Okay, could you maybe provide a few specific examples of what an integrated delivery model looks like? Like kind of like maybe walk me through a small workflow or a sample workflow, and also how the engineers fit into that and how they can think about this kind of model and get it into their workflows.
We can start with supply chain, right? So I mean, currently, feedback from the steel mills is now we're sitting here in mid-June. Some of the roll dates for certain materials aren't getting rolled until February. So right off the bat, 6 to 8 month delay in receiving those materials. The faster we can get a project to the point where the fabricator is cleared to order materials, so getting advanced bills of materials executed, that frees us up to make those purchases. We're very much in tune with the supply chain challenges. And again, the early coordination, specifically amongst the engineering teams, to identify any issues, because the worst thing that could happen is you find an issue in the field and have to reorder inventory or certain pieces, and you're looking at a multi-month delay on being able just to receive those materials. So it's in an environment, it's a very dynamic and exciting time in our industry, but also presents very specific challenges that if the engineering teams are coordinated ahead of time and can really do their work through their processes together, it makes everything more efficient. And Todd, we've seen that time and time again. We're doing some work with Clark Construction, right, where we've actually been brought in the design phase. So it's a limited release, very small scope of work in the beginning, but then through once the project becomes fully vetted, and the problems are identified and resolved, then it turns into a much significantly larger, obviously, opportunity for the entire construction process. But countless examples of how that coordination has saved a lot of time and money downstream.
Okay, thanks. So one of the benefits of my job is I get to talk to a lot of different subject matter experts. And so I would say you being a steel expert and a public sector infrastructure experts, could you share some insight on steel and public sector infrastructure that engineers should know about more so that they can be kind of up to speed in those particular areas?
One of the trends is the growing focus on sustainability, and engineers are being asked to think beyond structural performance and understand how material choices affect the broader projects. Another trend is the digital delivery, so BIM coordination, 3D modeling, laser scanning. model-based workflows have become standard tools on projects. Quality of information sharing, between stakeholders is a direct impact on project success. We're seeing heightened interest in prefabrication and integrated project delivery. Owners and contractors looking for ways to improve schedule certainty, but at the same time, infrastructure investments, manufacturing expansion, energy projects just creates opportunities, but also puts significant pressure on workforce development, execution, and just the industry overall, our ability to keep up with the demand, which has just surged over the past several months.
Sure. So how is these sustainability expectations kind of affecting the things that you do and what you're able to provide to people?
It's always been part of the solutions that we provide. Most of our projects have typically have had a requirement for buying American-made products. Certain specialty materials we do source from various locations, but it's put more there's more and more pressure on being able to source the materials, understand where they come from, what mill and what location, and the chemistry behind it, because those are all important factors in the documentation requirements that we need to track from when we first cut that PO to order that to when it's ultimately hung in the air and attached on a data center. We need to be able to trace that steel all the way back to the source. So that's critical, but fortunately, it's something that we're very accustomed to and have been doing it for a long time. So another great reason why picking the right partner is so important, especially in this environment.
Okay, so a lot of engineers work on projects where they have to decide which kind of materials they're using. A lot of them, steel is if not the choice, it's certainly a consideration. What are some things that they should be thinking about as they're deciding which materials to use, which companies to partner with? What are some of the things that they should be thinking about as they're going through these decisions?
Again, certainly availability of materials and lead times, right? That's going to be critical. The engineers are very good at making the right choices in terms of what type of structure, the load that it's going to have to bear, the length of the spans, right? That's something that our teams and our customers are obviously very very good at. The coordination, though, getting back to coordination, that's just right. We keep saying it over and over again, right? But truly, it's that communication between the groups that can ultimately lead to success. But the procurement process, while the timing has changed and the need to get orders out faster to ensure that the product availability. Beyond that, it's very much what we've been doing for the entirety of Extreme Steel's existence and what the fabrication industry does in general. But the materials choices are obviously critical for execution.
Okay, so following up on that communication thread, what is one piece of advice you might give to engineers working with steel contractors, other contractors, or procurers, that they can improve that communication gap? I know it's getting involved early, but what does that actually look like? Is that involving people in meetings earlier? Is that sending out that first email as soon as possible? What does that look like?
I think the the single biggest piece of advice I would have for our engineering folks out there is think beyond the calculations. A lot of our project problems aren't caused by calculations, they're caused by coordination issues. They're caused by communication gaps or incomplete information, decisions that are made without fully understanding how they might affect the fabrication or the field installation. Engineers who bring the most value are usually the ones who understand how projects are actually built. They spend time in the fabrication shops, they're visiting the job sites, but talking to the detailers and the fabrication and the fabricators and field crews, the more you understand of the entire process, the better engineering decisions you ultimately make.